Okay, welcome to 5.2. So now we are still going to solve systems, but now we're going to be using a different method called substitution. So we're going to write out a list of steps as we go along to kind of help you with this process. So what substitution is it wants to for you to plug in something into another equation where it's going to make everything in that one equation in terms of one variable, because we cannot solve equations where they have both x's and y's in there. But if we have only x's or only y's, then we can go about solving these equations. So our first step for this particular problem is already done out for us, but I'm still going to write it down because we will need it for the other ones. So it is to find a loaner, that's what I call them, loaner variables, the variables that are all alone, they have a coefficient of just one. So find a loaner variable and solve for it. And what I mean by that is you're getting it all by itself on one side of the equal sign. So this one, our y would be our loaner variable, and it's already solved out for. I have 1y equals 4x minus 1. So this part's already done. All right, so my next step is going to be substitute that expression. Substitute that expression into the other equation. So everything is in terms of one variable. And if you need to pause this right here and just write it down, these steps are going to be very, very helpful in your notes. Okay, so what does this actually mean? Substitute that expression. Which expression am I talking about? I am saying what y equals into the other equation. So if I know that y equals 4x minus 1, that means this y has to equal 4x minus 1. Okay, so that's what I'm going to do. I'm going to substitute what y equals in for this. So it's kind of like if I said, well, y equals 2, then I would plug in 2 for y. But now y equals 4x minus 1, so I'm going to plug in the whole thing. So this is kind of what I like to do. It might help you see it, what you're doing a little bit better. I write down everything that's not y first into this, and then I open up with parentheses what that y is. That just lets me know that I am plugging in something different over there. Then I have to look over here. What am I plugging in for y? I'm plugging in 4x minus 1. Okay, so now what does it look like we should do? So over here, more often than not, we're just going to solve this equation. Usually that means we're distributing first. The only time where we don't have to distribute is if we just have like plus 1y, but even if we just have minus a y, or definitely if we have a coefficient in front of y like we do over here, definitely have to distribute, and then we just solve the equation. Okay, so I'm going to distribute the negative 5 over here, so make sure you're doing that whole negative 5, you're distributing that. So I have 6x over here, that does not get distributed. Negative 5 times positive 4x is negative 20x. Negative 5 times negative 1 is a positive 5 equals negative 2. So make sure you are really paying attention to these signs. All this work and stuff, if you miss one sign, it's going to mess everything up. Then we combine like terms. 6 minus 20 is negative 14x plus 5 equals negative 2. Subtract 5. And negative 14x equals negative 7, negative 2 minus 5. And then we are dividing both sides by negative 14. And then be careful over here when you're simplifying. So over here, I have negative 7 divided by negative 14. 1, a negative divided by a negative is going to be a positive, but 2, make sure if the numerator is smaller than the denominator, that means you're going to be left over with a fraction. So a lot of you guys are very tempted to put 2 over here, but it's really just 1/2. And then, are we done solving the system? If I know that x equals 1/2, are we done solving the system? And hopefully you guys, after watching that last video, are like, no, because all of my systems for ordered pairs, or I'm sorry, for all of my solutions for systems have to be ordered pairs. So I only have the x value of the ordered pair. I have to solve for the y value as well. So that's going to be our last step over here. So plug answer back into an original. Oops, origin now. You know what I mean? Back into a original equation to solve for the other variable. Okay, so I want to take this 1/2 and I want to plug it into an original equation. So I want to go back up here. And if I'm solving for y, you can pick either one of these equations, but it's probably just easier. Like I'm solving for y, so it's going to be easier to just plug this one into there. So I got to move my camera back down over here. But what I'm going to have is y equals 4. And then instead of x, now I'm plugging in the 1/2 and then minus 1. And then I just solve this. 4 times 1/2, you just cut it in half, which is 2. 2 minus 1 is just 1. So now that I know that y equals 1, now I know that my solution, and always make sure you are putting your x's first and your y's second, my solution is going to be 1/2 and 1. And again, if you want to double check and make sure this is right, you can always plug it back in. So obviously we just did that one, so it works. If I do 6 times 1/2, that is 3. And then I have minus 5. So I have 3 minus 5 times 1 is just minus 5. 3 minus 5 is negative 2. So I did this one correctly. Okay, so that's how we're doing substitution. All right, let's do a couple of other examples. And hopefully these should go by a little bit faster. So the first thing that we have to notice over here is that we do not have a variable solved out for yet. So we have to make sure we are getting one variable by itself on the left side of the equal sign. So this is what I mean by pick a loner variable. What is the only variable over here that has a 1 as a coefficient? And that is this guy. So he is the one that I want to solve for. And how I'm going to solve for him, just subtract the 3y, get it to the other side of the equal sign. So now I have x equals negative 3y plus 5. And again, if you are not subtracting this 3y over, it's going to be wrong. It's going to throw your whole equation away. So make sure that you are doing those legal math moves over here. So this is going to be the equation that I'm working with. And then again, I'm substituting in the expression. So x equals negative 3y plus 5. So I want this x to equal negative 3y plus 5. And remember, I usually just open this up and I say I'm going to plug in something for x over here. And then I just write everything else down the way it is. And then I can plug in my negative 3y plus 5. And then I'm going to just distribute and solve for this. So negative 2 times negative 3 is negative 6y. I'm sorry, positive 6y. Do it. Again, watch your signs. Even if you make a mistake, that's why they make whiteout and pencil erasers. So negative times a negative is a positive. So always double check. If you get those really like funky answers or something, always go back through and double check your signs, and it's probably a sign mistake. Negative 2 times positive 5, that one's negative 10. And then we have plus 5y equals 23. Combine like terms. So 6 plus 5 is 11y. Minus 10 equals 23 plus 10. 11y equals 33. And then we just have to divide by 11. And I get y equals 3. So that's a nice, clean, solid answer over here. So I have y equals 3. Now I just want to plug it back into an original equation. So I'm just going to plug it back into the top one. So I have x plus 3. And now I know that this y equals 3. So again, I'm plugging in my answer over here in for my y now, so I can solve for x. And then this whole thing equals 5. So now I have x plus 9 equals 5. Subtract the 9. X equals -4. And then I am not done until I write this down as an ordered pair. So make sure your x goes first. So I have -4 and 3. So this is my final answer. You will get points marked off on a test or a quiz if you don't write down that final answer, even if you have both of these parts. I want to see you guys write it as an ordered pair. Okay, again, you can pause it if you need to write anything else down. Going on to this one. Now, these ones, they love to like throw at you on the SAT and stuff like that just because they look super, super hard, but there is a trick to these. So notice how like our first step was always like, find that loner variable. What's just going to have a coefficient of 1? And you're just like, well, nothing does. That's because I don't want to deal with fractions. Whenever possible, I want to just get rid of them. So we're going to write down a little trick over here. Cancel out the fractions. And we've already done this a couple of times when we were turning things into standard form. So cancel out fractions by multiplying by a number that will cancel all denominators. Okay, so what does this mean? Do you remember us doing that where when I said like, oh, if you have one denominator, you're just multiplying by that one number. But if you have two denominators, or in this case, I have 3 different denominators, I got to find one number that's divisible by all 3 of these. So obviously it's not going to be 2 because I can't do 2 divided by 12. That's going to give me a fraction of 1/6. I want a whole number. So my little trick for these is start with your biggest number. Can I take 12? Obviously 12 is divided by 12. Can I do 12 divided by 4? And the answer is yes. Can I do 12 divided by 2? That answer is yes. So for this one, my number is just going to be 12. And again, I'm going to have to distribute that to all 3 of these guys. Okay, then I have to do the same thing down over here. So now I only have 2 denominators. I only have a 5 and a 2. So I'm going to start with the biggest number. So can I do 5 divided by 2? That's a solid no. So now I'm going to do my next multiple of 5. So I'm going to go to 10. So obviously I can do 10 divided by 5. Can I do 10 divided by 2? The answer is yes. So I'm going to have 10 over here, and I'm going to distribute to everything. So this is where you have to be a little bit more careful. So now 12, and I always do the division first and then I multiply by the numerators. 12 divided by 12 is just 1, and then I'm multiplying it by 1. So that's just going to give me an x. 12 divided by 4 is 3. Going to multiply 3 times 1, which is just 3. So x plus 3y. And then this last one, I have 12 divided by 2, which is just 6. And then 6 times 3 is going to be 18. And then I'm going to do the same thing over here. Start distributing the 10. So I'm going to do 10 divided by 5. That's 2. 2 times 2 is 4. So I have 4x. Go over here. 10 times 1/2. Anything times 1/2 is just half of itself. Or you could do 10 divided by 2, which is 5 times 1. Don't forget that this one is negative, so it's going to be -5y. And then the 3 doesn't have a denominator, so 10 times -3 is just going to be -30. So now you have to ask yourself, now no more fractions. This is just a regular problem. I have to now find my loner variable. So now this x has a coefficient of 1. So I'm going to subtract the 3y over. And again, I know at least half of you, when we practice this tomorrow, you're not going to subtract that over, and that's going to throw your whole problem off. So make sure you're really starting to look out for that. X equals -3y plus 18. So I solved for my loner variable. x equals negative 3y plus 18. So this x is going to equal negative 3y plus 18. Always make sure that you guys are plugging it into the other equation. Never plug it back into itself. Otherwise, it's just going to cancel everything back out again. So now I'm going to open that up. I write down everything that's not the x that I'm substituting in for, because I want this x to now be negative 3y plus 18. Okay, and then I'm going to distribute. So 4 times negative 3y, hold on, gotta move that down so you can see what I'm doing. 4 times negative 3y is negative 12. 4 times 18 is going to be 72. And then minus 5y equals negative 30. Combine like terms. Negative 12 plus negative 5. Again, make sure two negatives added together is a bigger negative. So this is negative 17y plus 72 equals negative 30. Subtract 72. This is going to be a big number. So now I have negative 17y equals negative 102. Oops. Divide by negative 17. And I'm just going to write it over here. Y is going to equal positive 6. Okay, but again, I am not done yet because I have to stick it in back into one of my original ones. Now, my original ones, I really don't want to plug it back into here with all these fractions. Once you turn your original ones into whole number systems, just pick one of those again. I'm going to just pick the top one. So I have x plus 3, and then now I'm plugging in 6 for my y equals 18. So then x plus 18 equals 18. Subtract 18. And this is still okay. I can have x equals 0. So 18 minus 18 is 0. That just means that my solution to this one is 0, 6. Okay, so my solution for this one would be they'd be crossing just on the y-axis. And that's still okay. That's still a solution. That doesn't mean no solution whatsoever. Okay, the next one that we're about to do, I think maybe I'll just show you the little trick and then maybe we'll just do it in class because I don't want to take too much time in this video. So we just finished working with fractions. Now we have a bunch of decimals. So we still want to cancel out the decimals. So cancel out decimals. But now we are going to only be able to multiply by really special numbers by multiplying by So notice how decimals are in tenths, hundredths, thousands, 10,000s. So that's the numbers we're going to multiply by now. It just makes a little less of the guessing game going on over here. So it's got to be one of these, a one with however many zeros. And this is how you can tell which one you're multiplying by. Ask yourself, you want to multiply by the one with the highest decimal place. And this is what I mean. So this one is tenths. I have 1/10 over here. This one is in the 100th spots. I have 300ths. This one's in the 100 spots. I have 500ths. So that means I want to multiply by the biggest one. So I have hundredths over here that I'm multiplying by. This one is just a tenth, 1/10, another 1/10, and then 6/10. So since they're all tenths, that just means I'm multiplying by 10. Whenever you're multiplying by 100, all that means is you are moving the decimal place over 2 spots for every single one. When I'm multiplying by 10, that just means I'm moving the decimal spot over 1 spot every single time. So however many zeros you have, that's how many spots your decimals are moving over. So this one, since I had 1/10 and I'm multiplying it by 100, this guy's actually going to turn into 10. And then 300th multiplied by 100, now this is just going to be 3. And if you don't believe me, go ask your calculator. And then 500ths multiplied by 100 is just going to be 5, and it's -5 in this case. And then multiplied by 10, just pretty much all of these numbers turn into whole numbers. So I'm going to have 1x minus y equals 6. And then I think we'll finish this problem in class just so I don't take up too much time. I'm just going to do one more problem with you guys, and that's going to be this guy over here. first thing I got to do is find my loner variable. So the only one with a 1 coefficient is this y. So I'm going to start by subtracting the 2x over. And again, notice how I showed my work. So y is going to equal negative 2x minus 3. So that means with my substitution, I am plugging in negative 2x minus 3 in for this y. So I have 6x plus 3 equals 0. Then I want to plug in negative 2x minus 3 in for that y. Distribute 6x, and then 3 times negative 2 is negative 6x. And then 3 times negative 3, negative 9, equals 0. Okay, combine like terms, and look what's going to happen over here. 6x minus 6x is nothing x. Some of you guys want to say it's 1x or 0x, but 0x is just 0. So these guys end up just completely canceling each other out. They are gone. They are nothing. So now I have negative 9 equals 0. Well, that's not true. So once your variables cancel out and you get a false statement, that just means you stop and you say no solution. I cannot do it. So if you were to put these equations into slope-intercept form, you guys would have noticed that they would have had the exact same slopes of each other, which means they would have been parallel lines. So that's why it's no solution. We just showed it algebraically instead of with a graph. Okay, so we will practice these guys tomorrow. I hope you enjoy the rest of your beautiful Sunday.